So we're gonna discuss about the introduction to BGP, I would say. Now we have seen kind of protocols uh, we've seen static routing and we've seen dynamic routing. In static routing, we saw ways how we can implement static routing by using either static or by using default static or by using floating static. And then in dynamic routing, these are divided into two, I would say, categories. One being iGP and the other one being eGP.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
In iGP, there are different protocols, be it routing information protocol, then you have eIGRP, and then you have OSPF. I would say ISIS will also be counted in the same, but we're not concerned about ISIS as of now. So these were the three protocols that we saw into IGP, which comes under the umbrella of dynamic routing protocols. And then we need to see something called EGP, Exterior Gateway Protocol, where BGP, Border Gateway Protocol, comes up. And this is the most widely used protocol, and this is like a major protocol because of which you can say the internet is alive or the internet is working smoothly in the world today. So it is no longer used majorly for inter-organization or inter-organization communication. So think of it where it's used basically uh, is, let's say you have, this is kind of a campus A which is situated in New Delhi. And then there is an ISP connection, and then here is somewhere, I would say, campus B of an organization situated in, let's say, Dubai. Now, if you enlarge this campus A, there might be devices that are basically connected, like this can be your edge device or core device, which actually has a connectivity going towards the internet. And then this might be connected towards multiple of the internal devices, be it like switches over here, then you have some other switches over here, some other switches over here, and then these are kind of users that are actually accessing these. So like that can be a scenario how an internal network is communicated or how an internal network is working. Over here in campus B, the scenario can be same, that there is an edge device, and this edge device is connected to several of the internal routers, right? And then there are, you can say, people who are looking forward to access it. And then you have a connectivity going outwards towards this. So when this intercommunication between like these devices needs to be done, you can implement protocol like OSPF, you can implement protocol like eIGRP, and you can implement protocol be it like RIP as well and static as well. That's all about the internal communication when the communication is limited in this window. But if you want to communicate from here to here directly by crossing the internet, by reaching out on the public internet, then you need to take help of BGP, Border Gateway Protocol. Are we good? Do you understand where we actually need to use it?
Yes.
So the router's primary function when we look at it is to move the IP packet from one network to a different network. And a router learns about non-attached or indirectly connected networks in the topology through configuration of either static routes or dynamic route. So when we talk about dynamic routing protocols, these routing protocols, be it OSPF, eIGRP, and all, they do distribute uh, network information via different advertisements that they work with, right? So they kind of provide updates as well without intervention when a topology change in the network occurs or so. And then the design requirement or hardware limitations may restrict IP routings to static routes or so, but which do not actually accommodate topology changes very well. But when we look at bigger scenarios, when the picture actually gets wider and wider in terms of the complexity of the network, then you shift your focus from static to sorry from static, I would say, to dynamic. Okay, as the size gets bigger and bigger of the network. In the dynamic as well, you would transition from RIP to eIGRP and to OSPF. That's how the transition is going to work. But with dynamic routing protocols, you can say that routers try to select the best loop-free path on which to forward the traffic and all. So you can say that the network can actually be connected from one device or from one, you can say, building to other building, if you do not actually have need of implementing connectivity with ISP. It's like you can still have campus A and campus B, and let's say campus C, and let's say campus D. If you have this campus situated in, let's say, in the same, you can say, tech park, and then when you want to make reachability available here, you can connect A with B, B with D, D with C, and C with A. You can also have a mesh connectivity between them as well. That is also possible, right? Over here, you won't need BGP. You can work with OSPF in this particular domain pretty well because it's all internal communication that's happening. The picture of using BGP comes into play when you're looking further towards using the ISP connectivity in order to reach out to a remote network that is situated across the web. So that's where the BGP comes in, as I said. And now, when we talk about BGP, BGP is called as uh, path vector routing protocol. I'll be telling you about the fundamentals that we actually use for this. But yeah, BGP is called as kind of a path vector routing protocol. So when you talk about path vector routing protocols, you actually need to understand about how the things about autonomous system selection and all these things actually work in this. So when you talk about path vector, uh, or when you talk about how BGP neighborships are done, there are certain characteristics that I'd like to make you familiar with before we jump in directly into the lab and so. So when you think about BGP, the very big difference, sorry, yeah, the very big difference that you see here in BGP is BGP uses manual neighborship. So the thing is same. When you have two different routers and these routers actually needs to form up connectivity, maybe that's an OSPF connectivity or so. As soon as you turn on your router one's OSPF config and router two's OSPF config, the router one and router two are going to exchange hello on a multicast network. Okay, maybe 224.0.0.5. And then once the neighborship parameters kind of matched up, then your device is kind of going to become OSP of neighbor in that scenario. That's how the thing works. But if you look at, I would say, if you look at something that connects you over BGP, then you would rarely be looking forward to connect devices like routers that are directly connected with each other and make them BGP neighbors. It's rarely going to be a scenario. Okay, so possibly that you might be having an autonomous system number over here, or autonomous system number, let's say 100 here. I'm just giving an example. An autonomous system number 200 over here. and then that's like R1, and that's like R2, and then in the middle you have certain ISP, and then you have an ISP connectivity from here to here and here to here. So when you want to become neighbor from R1 to R2, you need to manually create the neighborship. We call it as manual neighborship. Okay, and there must be an underlay protocol running up in order to connect these two, because it's possible that on R1's end you probably are using an IP address called 11.0.0.1, and on R2's end you are using 22.0.0.1. Okay, this might be the possibility. So you are building up a neighborship from 11.0.0.1 to 22.0.0.1, which are not at all same subnets. So in all, BGP kind of have the ability to create neighborship between this. Of course, there are going to be routers because this is an overlay scenario. Or if you look at its underlay scenario, you probably are going to have your R1 here connected to ISP1 and connected to ISP2 and connected to ISP3 and connected to ISP4 and so many others, and then you are going to reach out to R2. So it's like you are going to use a connectivity from here to here. And this is how you're going to become a direct neighbor from point A to point B in BGP. Okay. So when you look at the connectivity options that are available in BGP, one of the options that you have is called as iBGP, and the other option that you have is called as eBGP. iBGP stands for interior BGP and eBGP stands for exterior BGP or internal or external BGP. That's how you can refer them. What is internal BGP? Internal BGP is a scenario when you have multiple devices in same autonomous system number, but those devices actually needs to become BGP neighbors. And then you have a scenario of eBGP when you are basically creating neighborship within or between the different autonomous system number. You can say edge routers. That's how the scenario is going to be. Now, can you tell me why would you require something like iBGP? Varun, any thoughts? Or Vikram?
If we are having like we have some routers in the same AS,
Mm-hmm.
then we require if we want to create a establish a peering with them. So in that case, we will be requiring iBGP.
So you're saying that if we have some scenario like this, that you have your R1 here and you have your R2 here, right? Shall I directly connect them together?
Yes.
If I directly connect them together, then you're saying that in this case, if we form a BGP neighborship, this will be called as iBGP, correct?
Yes.
But what's the need of having this then? Can't I just create EIGRP neighborship in this scenario?
Yeah, we can create, but if we want to like um, advertise to run BGP in a larger network, in
Mm-hmm.
that case we will be requiring BGP. If I give you example like in ISP,
Mm-hmm.
we have like numbers of network, but it is in a same AS. In
Mm-hmm.
that case, we configure iBGP because the routes are very large, one, and the
Mm-hmm.
network is not small. It has many routers in a ring format. So in that
Mm-hmm.
case, we require BGP.
I got it. So that particular scenario would something be like that you have your ISP router here, right?
Yes.
In order, and then ISP definitely is connected with bunch load of networks that are available here.
Yeah.
Many networks. So this
Mm.
particular routes or these routes needs to be installed onto the R2, correct?
Yes.
Now, when you have R2 connected over here with the ISP router, all these BGP routes can be bought in to the R2's routing table, correct?
Yeah.
Now, if you have R1 as well, is it necessary to install the that like big of a routing table onto R1 as well? Or would you just summarize that particular route and throw a static default route from R1 facing towards R2? And then R2 will take care of forwarding that particular information out on the internet by netting or something else.
Yeah, we can do that.
Makes sense?
Yeah.
Then what's the need of iBGP here?
No, no, no. I am saying the cloud that you have created under the ISP. I'm saying to run there, to run inside the ISP.
Hmm. No, that I would say won't be the case over there, because when you talk about ISPs do not actually just connect iBGP peer. So even in ISP itself as well, when you are connecting that big cloud there, you can still have iBGP, or sorry, you can still have IGPs, be it OSPF, VIGRP or so. What I'm saying, that the diagram that I have drew you over here, this diagram can be inside this cloud as well, right? Because it's ISP, this particular router who's actually dealing with all the internal routes that you're working with.
Yeah,
Confusing?
but the additional thing is that BGP we can manipulate like our routes easily inside the BGP protocol.
That's all accepted. I agree those points. The debate, or you can say the question over here is, why would you have iBGP in your scenario when the major picture of using the major picture of using BGP itself is connecting different autonomous system together when you have an ISP in between. You can have iBGP. You have an option to implement iBGP here. You have an option to implement iBGP here as well. Why is this? Is that you, Vikram, who was answering the thing?
Yeah, it was Varun actually.
Okay. What do you think about this, Vikram?
Mm, maybe I'm not sure, but maybe we couldn't advertise the global networks in the IGP.
No, we can use redistribution and all.
Okay, yeah, I'm not sure, Abhijit.
Okay, that's fine. I'm expecting the same. I don't want you to teach me that. Why?
Yeah, because when you ask this question, right, it comes to my mind as well. I was gonna ask you this question in 5 minutes, but you asked it first. That
Yeah.
why we
So
couldn't use eIGRP.
I was
So
just curious to know about what you think about this, so that I can clear your thought process and
yeah,
make a
sorry.
better understanding. That's fine, man. Definitely. So here's the thing. We kind of use iBGP when we have a scenario like this, that this is one autonomous system number that we have. Then I have one router facing over here, the other router facing over here. And then I have R1 connected with R2, connected with R3, connected with R4, connected with R5. You get that? R5 is connected to one ISP, and R1 is connected to another ISP in this scenario. Okay? Now, the picture over here is, there are a bunch other networks that ISP2 is connected with. Probably, let's say that ISP2 is connected to my campus A. Okay? Because campus A's router has only single connectivity, which is ISP2. And then campus 1 is connected to, let's say, another network over here, can be said as campus C. And then this is campus B. Make sense? Now, when campus A's routes are going to be installed into the routing table of R1, these are going to be eBGP routes, because the autonomous system numbers of this and this is going to be different. Are we clear here? Any questions?
No.
No.
Then, if we talk about the same scenario from campus C to campus B, or R5 of campus B, that's going to be the same case, right? So it's like, if you have 70.0.0.0, this particular route is going to be installed in R1, and if you have 80.0.0/24, this route is going to be installed into R5, and this is going to be a BGP route, correct? Or rather, eBGP route that you're going to receive. Now, In order for R1 to, like, for example, let's say that there are people or there are networks that are connected over here, or even on campus C. Would campus C be able to reach out to campus A in this scenario? Definitely not, right? Because the route exchange is not happening over there. If I am running kind of an, over here, I am running, let's say, eIGRP. So my eIGRP routes are not going to be redistributing the internal private networks to a public network. Am I correct there? Because I probably might be using 192.168.1.0, 2.0, 3.0, 4.0 in my internal network, my private network. And these particular private, I would say, networks cannot be advertised out or cannot be redistributed out on the public network, because those are not routed IP addresses, or those are not routed networks that can actually be used. So what can be redistributed is, or what can be advertised is the network connectivity between this ISP and the R5. That particular network can be installed into the routing table of campus C's routing table. Makes sense what I'm talking about? Confusing? Or you good?
Uh,
This is still the
can you
half
explain?
story.
Can you explain it one more time, Abhijit?
Sure. What I'm saying here is, when you have campus A and campus C there, campus A is connected to one ISP, that is ISP2. Cool. Campus
Correct.
C is connected to another ISP there. But then both of these campuses are not connected directly. They are connected through a transit campus, which is campus B. Cool.
Yes. Yep.
This campus B then have two WAN facing devices. One is R1 facing towards ISP2, and the other one is R5 facing towards ISP1. Correct?
Yes.
Is there any advertisement or is there any knowledge about network 70.0.0 to this particular fabric? No.
No. Yeah.
And vice versa as well. There is no knowledge about 80.0.0 to this particular network.
Yes.
Now, when you're thinking about this approach, then your 870.0.0 network, this particular route will be advertised out to ISP2, and ISP2 will be putting that particular thing into R1's routing table as BGP route. Correct?
Yes.
Can this BGP route be installed into R2?
We
For
have to redistribute.
redistribution? Yes.
Yeah. If we are using eIGRP, we have to redistribute, right?
That's correct. But then, when you look at the design recommendations, according to this perspective, it is a foolish idea to redistribute outside networks into the internal router. Okay, because the routing table size will be so large that the router will not be able to handle the thing, because internal routers are not as powerful as the WAN facing routers. Correct?
Uh, okay. Now it makes sense.
Yeah. So when you kind of are not making this particular routes installed into the internal networks, but then you also need to make sure that R5 has the reachability to this 70. Correct?
Yes.
Because as of now, it's just R1 that is making out to 70. But R5, because the route are not being passed to the R5, or even to R2 or R3 or R4 to R5, your R5 cannot actually reach out to 70.0. Are we good here? And same happens with the other side as well. Like R5 is going to reach out to 80, but R1 is not going to reach out to 80 because the route is not being propagated out towards R1 from R5. Any questions still here?
No.
Perfect. Now, this connectivity from here to here is going to be called as eBGP, because the autonomous system number of campus A and campus B is different. And this connectivity is also called as eBGP because the autonomous system number of campus B and campus C is different. Are we good here?
Yes.
But in order to install, or in order to propagate the BGP routes that are being installed onto R1 on R5, you need to build up the manual neighborship. between R1 to R5, and this neighborship will be called as iBGP because the autonomous system numbers are going to be same for them. Questions?
No.
You understand the purpose?
Yeah.
Now, when the routes are actually being exchanged, like from R1 to R5, you're gonna see then the BGP route for 70, okay, and for 80. 70 being eBGP route and 80 being eBGP route. You get that? But this is not how the case is going to be. When you see 80 route, okay, on R1, that 80 route is going to be iBGP route, and then the 70 route is going to be eBGP route. You understand that? Because 80 is coming from a router which is part of same autonomous system. That's what the difference is between iBGP and between eBGP. But when the routes are being installed on R1 and R5, these routes are not at all going to be installed onto R2, R3, or R4. So the routes are directly propagated from R1 to R5. Of course, by using underlay fabric, which is the route updates are definitely going to be sent from R2 to R3 to R4 to R5. But R3, R2, oh sorry, R2, R3, and R4 will just be relaying that information to the next router, and they won't be installing the route into their local routing table at all. Are we good here? Any questions?